Hello everyone. Today we're going to continue our quadrilateral discussion and we're going to discuss trapezoids. Definition: a trapezoid is a trapezoid has at least one pair of parallel sides. So that means that a parallelogram, rectangle, and rhombus and square are special trapezoids. Now if you recall our diagram, also underneath the trapezoid, we had another special trapezoid, which is the isosceles trapezoid. An isosceles trapezoid is a trapezoid in which the non-parallel sides, also called the legs, are congruent. So that means we have a pair of parallel sides, and the non-parallel sides are our congruent sides. So our theorem is, if a trapezoid is isosceles, then the base angles are congruent. Now, it really doesn't matter which ones you're referring to as the base, whether it's the ones with the short side or the long side. So in my trapezoid here, I would say that angle A is congruent to angle B, or angle D is congruent to angle C. Both those are base angles. Then also, if a trapezoid is isosceles, the diagonals are congruent. And this is why we can't just use congruent diagonals to prove something's a rectangle, because it could be an isosceles trapezoid. So in my trapezoid here again, which is isosceles, where AD is congruent to BC, then our diagonals, which are AC, is congruent to DB. So now we can use these properties, just like we have with the other shapes, to find missing information. So in number 1, that is an isosceles trapezoid. These two sides are labeled congruent. So therefore 3x minus 3 equals x plus 5. So I solve that, and I get x equals 4. For number 2, again it's labeled an isosceles trapezoid. So that means my base angles are congruent. So that means 6x plus 20 is equal to y. However, it is also still true because these two are parallel, these two lines are parallel, that 4x and 6x plus 20 are supplementary because they are same side interior angles of parallel lines. So I can use that to solve for x by saying 4x plus 6x plus 20 equals 180. So then I just solve for x, and I get that x equals 16. Now, knowing that x equals 16, we can find y because y is equal to 6x plus 20. So it's 116. So I want you to, so now let's do number 3. So number 3, we're looking for that height there. So knowing this is isosceles, that means I could draw another height here that would be congruent, and that creates a rectangle in the middle. So that means that the triangle on the left and the triangle on the right would be congruent because of hypotenuse leg. So that means this is still 13 because those are my legs that are equal. If the top line is 24 and the bottom line is 34, then the two missing parts combined make 10. So then each one is half because they're congruent. So they are 5 and 5. So then to find x, I'm using the fact that this is a right triangle. So it's 5 squared plus x squared equals 13 squared, because I'm using the Pythagorean theorem. So I'm just doing that algebra. So x equals 12. Now, To prove a quadrilateral is a trapezoid, I just need to show that I have one pair of opposite sides parallel. To prove it's an isosceles trapezoid, I need to show it's a trapezoid and that the legs are congruent. Or I need to show it's a trapezoid and the base angles are congruent. So now I want you to pause and I want you to give this proof a try and then come back. So to do this proof, what I did is I started off with the fact that I know that AECD is a parallelogram. So that means that AE is parallel to DC and that AD is parallel to CE because opposite sides of a parallelogram are parallel. So then to establish that the larger figure is a trapezoid, I put a step that I would be fine if you skip, that AB is parallel to DC because extensions of parallel lines are parallel. Now I know that angle A is congruent to angle CEB because when I have parallel lines, there's a transversal here. So those two angles are congruent because they're corresponding angles. Substitution then says that angle A is congruent to angle B. And so ABCD is an isosceles trapezoid. It has one pair of parallel sides with base angles congruent. So here's our last proof for today. So again, I want you to pause and I want you to try it and then come back and check. Okay, so for this proof, we already knew that ABCD is an isosceles trapezoid with AD congruent to BC. So I went ahead and said that angle DAB, which is this larger angle over here, is congruent to angle CBA, which is this larger angle over here, because the base angles of an isosceles trapezoid are congruent. I then said that AB is congruent to AB, reflexive property. So then I know my triangle DAB is congruent to triangle CBA because of side, angle, side. Then using that, I got the smaller angles. DBA is congruent to CAB by CPC/TC. So if you have any questions on any of this, please ask me during class.